Here we're going to simplify rational expressions. To simplify rational expressions, we use the same basic principles as we do with fractions in dividing, multiplying, and simplifying them. And a rational expression in its simplest form has no common factors in its numerator or denominator, so that's our goal. This one here is a binomial over a monomial, but you'll see that it doesn't really matter what they are, the process is the same. First, we always remove common factors. So if I have a look at the numerator here, I'm going to take 5 out as a common factor, as well as the variable x. So if I remove 5x to the front, 5x times what gives me 15x squared, or 15x squared divided by 5x, is 3x. Then 5x into negative 10x is minus 2. So I've factored out the numerator. Now, since the denominator is a monomial, there's no real factoring out, but what you can see, or hopefully what you can see, is that the 5x here and the 25x squared have a factor in common. So I'm going to rewrite this 25x squared in my denominator with a 5x removed from it. So if I divide it by 5x, I'm left with another 5x, because 5x times 5x is 25x squared. Now we can see that they both have 5x in common, which means they can be cancelled out the same as you do with a fraction. So now what you are left with is 3x minus 2 in the numerator and 5x in the denominator, and you can see that we no longer have any common factors, so this is your simplified rational expression from your original. Now there's something else we have to take into consideration when providing our answer. This denominator here contains a variable. So you need to consider what values for that variable will make this rational expression not exist or invalid. Now we all know that we can't divide by 0. So what value of x would make the entire denominator 0, and that is 0. So this simplified expression would work only when x is not equal to 0. So this very important piece of information is also required. Here we have a rational expression as a binomial and a trinomial, and we're going to simplify it. Now remember that a rational expression in its simplest form has no common factors in its numerator and denominator. So we need to have a look at the numerator and denominator separately. I'm going to do the numerator first. And we always remove a common factor. Here we can remove the value of 7 and divide each term. So we're going to end up with x plus 8. Now we'll have a look at our denominator. So I'm going to use the product sum method, where negative 40 is my product and 3 is my sum. So I need two factors of negative 40 that add up to 3, and that is negative 5 and positive 8. So I end up with x minus 5 and x plus 8. So you can see here the numerator and denominator now have a term in common, so we can cancel those out, and we are left with 7 over x minus 5 as our simplified form of this rational expression. However, we need to take into account the exceptions for x. Now our denominator can never be 0. So if we have a look over here, we still have an x plus 8 in the denominator, even though it's cancelled out. So for this term to be 0, x would be negative 8. So therefore x cannot equal negative 8. And then for this term to be 0, or what we're left with in our denominator, x can also not be 5. So the simplified version of this rational expression is 7 over x minus 5, where x cannot be equal to negative 8 or positive 5, because that would result in the denominator being 0, and this cannot happen because we cannot divide by 0. Here we have a rational expression that we're going to simplify, and we know that there's going to be no restrictions on our x variable. And the reason we know that is because there is no x value in the denominator, therefore it can never be 0. So we approach it the same way, remembering that the goal is not to have any common factors in our numerator and denominator. So let's start with our numerator. By removing the factor of 18, we end up with x plus 2. 36 we can't do anything with, but we can recognise that 18 is a factor of 36, so I'm going to take that factor out. Now you don't have to do this step, you can simply divide by 18. I'm just doing it so that you can see what I have done. Now the 18 and 18 cancel out, and I end up with x plus 2 over 2 as my simplified expression for the first expression we started with. There are no restrictions here again because there are no variables in this denominator. So therefore the 2 will always be 2, and we can always divide by 2 no matter what our x value is. The answer is x plus 2 on 2. You do not need to state this, however it may ask you, so you can tell that there are no restrictions simply because there's no variable in the denominator.